Hi there, and welcome to yet another stream. So I've laid out these overall possible plans for today's stream. Um, um, yeah. Um, yeah. So this is some of the stuff I might do. I'm pretty tired today, so let's see how far we can go in terms of getting stuff done. Yeah. I'm just gonna mess with some stream stuff and then I'm gonna get going. Mm-hmm. Bup, bup. Uh, I'm just messing with some Streamlabs stuff. Okay, whatever. I think things should be somewhat set up. Okay, so I would like to be able to place a building and then get the building data in some kind of panel down here. Instead of it being part of the what do you call it? Well, maybe I want a sort of like a panel where I can swap between different objects in general. I mean, being able to click a resource and get the game data and then the potential editor data. I don't know. Yeah. But first I'll do the stuff that I actually wanted to do in the last episode. Let's see, row actually here. Let's create a series of rows and columns. maybe even white here. Let's see. So this is the columns. So if that is on the x-axis, that needs to be set like c times 1f here. Of course, we want something like this. And then we want the C part to be maybe just 0 for now. And then oh, this is the Y component. Let's just create it at 1Y here. Okay, let's try that. Yeah, so we have, well, let's lower them a bit. Well, and then they need to be minus 0.5, minus 0.5. And let's see. And let's +1. Let's see. 1 maybe. Maybe even lower then. And let's actually set this to -1. Yeah, we can lower them even more without getting any C fighting. Let's just set flow, const float, y offset 0, 0, f. Okay. Still need to lower it. Oh well, I think actually the what do you call it? The faces of the chunks, or rather tiles, are exactly at 0. So we could potentially make this very small and still do something. All right. Then for each row here, let's see, -1, and then game chunk times 1, and then this is supposed to be row times 1 minus 0.5 then. Let's try doing something like that. And we have our grid here. Okay, we still need +1 on the rows here as well. Okay. That's fine. Okay, we do have a bit of C buffer fighting whenever we zoom out far. Okay. That's fine. And in the build tool, I have a restriction. Let's see. Game trunk width -1, I guess. So, okay, of course this is a bad example. Okay. This should crash us. Yeah. Okay. Why aren't we? Huh? Oh, it actually checks the chunks outside, all with clamp values. Hmm. We will make sure that this doesn't overflow right now, or rather check something outside of bounds. Let's see. There we go. Then we don't need this. And let's do like that, and then else. We don't need to do anything because and let's move this outside. And then check tile buffer. Okay. Of course, this can't be built. Okay. So now we have actually. Oh, it still allows us to build here. Why is that? Is it just because? It doesn't even bother. I mean, let's do 3, 6, 8, 10, 12, 14. And what's our 14? Huh? Oh, of course. This, I think. Yeah, so it does register whenever we're out of bounds up here. If we change this to less than this, we should be able to build, yeah, on the less tile here, and that's because of the, we're actually pointing at this one. Let's see. Less than or equal to this. Minus params expand plus 1. And this should be the same except for the C-span. Whoops. Okay, my music ended. Gotta fix that though. Yeah, okay, so this is somewhat too restrictive, right? There we go. Maybe the parentheses fixed it. Apparently not. Or, yeah. Let's see, so maybe we want to do actually this plus this -1 instead. CPOS, C-span. Is this better? Probably. Yeah, it seems to be working at least. For all except the C-span. And why is it exactly working for the C-span? It's like yeah, okay. Uh, well, oh, yeah, I'm testing with the wrong building. Silly me. Yeah, so for some reason the C-span is not. Okay, let's just print our mouse tile pos with our let's see, so uh, so 13 0 13. Span params. So this should be then this should be end up being 14 minus 1, right? Oh, maybe. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 13, 14, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Thirteen, of course. 12 is passable though. 12 is passable. That is weird. I mean, this should be the same, shouldn't it? Why isn't it the same? So this plus 2 minus 1, 15, 14. Yeah, that's true. It's actually equal to 14. Huh. But for some reason, this maps differently. This should also be 14. Because 13 plus 2 minus 1 equals 14. Huh? This is so weird. Is it because it's checking something else? Okay, let's see. Maybe it's because it's passing, but I just can't see it passed. We don't need this. Yeah, it's actually passing. It's related to the calculation itself, I think. This function just doesn't. Yeah, so it's related to that. So actually, we want this to be lower for both cases. So the C1 was actually being correct. The underlying algorithm, though, has some potential overflow. So let's just mark that for probably some overflow somewhere in this call. Okay. I don't know why it's allowing me to build an extractor there, but this is fine. Now it's restricted, but the extractor itself should of course not be able to be built outside that. So okay. Let's try stepping into this function here. Maybe we do get assertion errors. Or is it somewhere in here? Okay. Hello, how you doing? Why not use DirectX? Hmm. No, that's a bug. It's probably related to the mapping of the resource lookups. So probably when I generate the resources, yeah. Maybe the tile index calculation is wrong here. I mean, let's see. So 0, 0, 1, 1, 2, 2, 3, 2. 2, 3, 3, 3, 3, 4, 3. I mean, 2, 3, 3, 3, 4, 3. Or what? Well, this is off, isn't it? I mean, X is 2. That's 1. Then 3, 2 is here. Next line. Oh, no. 2 dot 3. 3 dot 3. 4 dot 3. And then, oh, it's just because it's created later. And it's different. Yeah, okay. So it's created right there, so it's still there. Okay, let's see. In our simulation stuff window. Let's see. File index. Unsigned int. Tile index. Yeah. So this should be 0, 1, 2, 3, 14, of course. No, 13. 14, 15, 16. So this should be 27, 28, 29, 30, 31. And this should be 41, 42, 43, 44, 45, 46, 47, which is this one. 55, 56, 57, 58, 59. 60. Yeah, so some of the tile indexes here are wrong. Yeah. Yeah, in general, the tile indexes are wrong, right? So we had 27, 28, 29, 30, which is 2.2, 31. That's fine. And then 41, 42, 43, 45, which is also true, 46, 47, or what am I messing up? 42, 43, 44, 45, 46, 47, that's true. Okay. And then 51, 52, 53. No, that's not correct. 45, 55, 56, 57, 58, 59, 60, 61. Uh, 70, 71, 72. Well, that's correct. 73, 74. Yeah, it's actually correct. So whatever this is looking up is not correct though. Because that doesn't contain a resource. Um, let's see. Let's do a breakpoint here. If the tile position is higher than or equal to 3, but also less than 6, and the C position here is larger than 2, but also less than maybe 6. Float temp. This will be our breakpoint. Okay, let's step into this one. 45. Let's see. This, of course, doesn't hold the indices. Okay. So I want to actually look up this. So it's like, whoops. So 1, 2, 3, 4, 5, 6, 7. Or so that's 6. Needs to be above 6, but below 14. And this just needs to be above 0. And like that. That's fine. It doesn't... Huh? Huh? Let's print it again. Mouse pause. C pause here. Oh. Oh, the C value is maybe... What? Yeah, that's true. Alright. Let's see. What? Should be fine, right? Oh, no? Inside. Huh? We're inside. Oh, it's because of the X one, yeah. So the X pause and the C pause is 3? What? I'm pretty sure the C pause wasn't 3. It was 9. Oh. God damn it. Looking for a typo. Don't assume you ever write the correct thing. Assume you wrote the wrong thing. Okay. So we're back. Having a bounded algorithm for that. Okay. Okay, let's see. Rendering types is not needed right now. No pipeline state needed. Okay. No rendering is needed right now. So in our building data store, building data expand. Okay. So we immediately encounter a challenge. Right now, buildings are stored by their, or rather, on the tiles themselves. We have created a building ID and that actually stores the global building ID for all of the generalized building data, which right now is this stuff here, which I'm not sure we even use. Do we even create that? When we call create building, yeah, we saw the X and C position. Okay. So how do we map from this data? And should it be this data that we actually store? Right now we just care if it's set. We could do something like we could do something like unsigned int type index. But then we would need a switch to determine whatever we're storing. This just creates the building and the draw data itself. It doesn't really create and get building subarray index is actually the function, I guess. Yeah, okay. So we actually have a function. Yeah. So if we simply store this subindex, let's see. And maybe we even and it will return 0, so it will get set to 0 even though we don't have any building logic. So maybe if we remove this and only use subindex instead, we would get something that is potentially a bit better then. Let's see. Okay. So this would store our subindex. Let's see, building type index, building type. So we don't actually update the tile data, or what? Oh, we do down here, right? No? Huh? We don't update the tile data? So that actually means that we can create several? Or what? No? Uh, why not? I mean, why do you do anything? How do you decide if anything is worthwhile? Oh, I actually do update it here. I just didn't see. Okay, type index is our building type. Uh, okay, so our buildings will actually be some kind of sub-indexable thing that we store here on the tiles. So we can then do a simple switch on our, what do you call it, type of building. And the underlying index and get its information. So whenever we click something, let's see. Do we want it on the builder system? The overlay in the UI. Yeah, maybe I want to separate it. But maybe I do want to be able to. Yeah, this is tick based, so we can't use that. It's run from within our simulation, I think. Um, I mean, it shouldn't be coupled to the data stores. And I guess it's, so far it's part of the builder system itself. I guess. Okay. Now, procedural methods. Yeah, this should probably be something like this, right? Are we in trouble? Oh, yeah, because the struct itself is not public. Let's see, build a system dot header public. Okay. In our game state data, I think I'll delete this. Let's see. World space. Uh, tile pos space. Let's see, let's move this up here. Uh, array from mouse to through camera. Build a system. Building. Let's do state flags. Okay, let's redo this in the builder system. Building type. Okay. Uh, uh, UI related. Building selected. Index. Insert 2T building. Selected type. Uint actually. Okay. Let's fix that. Delete that iron amount. It shouldn't. Yeah. Void update building UI. Let's do a game state. Pass in here. Okay. And let's see how are our parameters here for ImGUI. Some of the same stuff is going to happen here. And let's I guess so let's see. Selected building. If game state building selected index. We will do this. And let's see. Panel width. No move, no save settings, no focus on appearing, no decoration, no nav. Let's see. And let's do the position is going to be the position here. as a float width minus the panel width. Okay. Where do we have a problem? Somewhere in here? What? Oh. Let's see. So, do we even draw our panel? No, because I haven't set the game state, of course. So if we do game state here, set the flag temporarily. Oh no, not this one. This one. Shouldn't we draw our panel? Well, maybe not. Building selected. So we don't create a panel. Okay. Oh, maybe it's because we don't draw anything to it. So let's do ImGUI text temp. No, nothing's happening. And let's do a oh, we don't call this method. Update UI, of course. There we go. And let's set some of this stuff back. Although we don't want this one. So our window is down here, which is not great, I guess. Let's do 300 pixels and 200 wide. And let's do some padding, of course. Let's see. Const expression here, float. Padding. X. Y. Minus the padding X minus the padding Y. Okay. Oh, you can't see it because of the YouTube chat, right? Yeah. Okay, so we will move it just for your sake. Let's do 100 in padding here. That didn't seem to be enough. There we go. And we have a panel here that is maybe a bit too high. It's not working? People have been joining pretty frequently. I'll check it though. I mean, I can still join it from the link in the description down below, so I guess I can't update it beyond that. Well, I don't know what's wrong on your end, but I'll post it in the chat. Try that, or try updating or reinstalling or rebooting your Discord. It, it works on my end, and people seem to be joining, so. Okay. It's the same link, so I don't know. Yeah, could be, could be. Okay, let's see. So, so let's see. Thank you very much. I'm glad you find it nice, and always appreciate the support. Okay, we will run into trouble in terms of build mode, right? No, this will check by itself, but this will not know whether we are in a build state and we're just clicking stuff, so um, A way to see if we're in a build state is, of course, just to check the vector, or rather this flag here, or not flag, but yeah. So if we click and we don't have a building selected, I mean, we should do some processing of these flags here. Yeah, so when we do the compilation here, I mean, these flags here should, for instance, is hovering window. Let's see, let's add is in build mode. Let's compile that flag. I just started with DirectX, and I don't know why I would use Vulkan. But there's no real reason. It's just because I started with DirectX, but you're not in build mode, but clicked. Let's see. Well, it doesn't work. This should work. Yeah, but clicked. Oh, of course. This is not the way. Equals 0. This is the way. This is how we check for that flag. Yeah, so now it registers correctly, blah, blah, blah. But if we're in build mode, it doesn't do anything when I click. Okay. So if we're not in build mode, we could even just mask this, I think. We could do something like Yeah, we could collapse it into a single flag check, but we don't care right now. Okay, so if we click, let's grab our potential building. So let's just look up the tile itself. Let's collapse this. And let's just do the same restriction here. Uh, I'm sorry, bro. I've been doing it for a while now, so it'll probably be too much to take in. But if you have questions, I can try answering them. Right now, I'm just checking whether my mouse position is within the current restrictions of the game world, which is limited to a certain amount of tiles. So let's just grab this method here for computing our tile index in our tile data store. Let's see, plus and let's do tile data store tiles. And let's just set it every time we click. Game state, let's not even check the value. We don't care about the value. If it's invalid, we will deselect. If it's valid, we will of course select. And then building, selected type, type index. And let's change the default value here back to -1. Okay, so if we click this building, immediately you see that we open the panel here. And else we just reset. So now we can even click somewhere else and close the panel. And let's do a series of calls here. Create ImGUI panel, or rather, create building panel, create selected building panel. Yeah, yeah. And let's do a switch once again. Break. Okay, so let's do some calls. We don't need this. Let's do a create selected building panel, and let's do this and okay. Right now, let's comment this out. So I'm not sure the panel will actually open right now because we have, oh, it does. So it's just creating a black one. Let's do ImGUI text unknown building. Otherwise, we do something like, oh, whoops, we definitely, oops, this is not where we want to do it. It was the wrong function. So we're back, right? Yeah. Yeah. Okay. Let's do ImGUI unknown building. Iron extractor 2x2, 1x1, and let's do maybe unsigned int iron content, the building data store dot iron extractors 2x2 building index dot storage, and let's add on an ImGUI text iron content u, and then our iron content here. And let's do it for the 1x1 And this should show us our iron content of it. Yeah, you immediately see, even though, I'm sorry, the text is too small for you to read, so I'll increase the size. Let's see. When I do... no, not currently. Let's see. Okay. Let's do set window font scale or what? It doesn't increase the font size, so... Oh, it's inside the begin call. Okay. Okay, now it's a bit too big, I think, or the panel is maybe too small. Okay. There we go, and actually we want another flag checked here. Let's do hovering window as well, so we don't deselect whenever we click the windows. So I should be able to click this all I want. Yeah, I'm clicking all I want. And now it's not closing, but if I click the gameplay area, it closes. Okay. Great stuff. So inside this, we shouldn't do this anymore. Let's see. So we simply have our resources here. Maybe even we want to split this. So let's do ImGUI text here. And let's do tile index here. And let's do this here. Okay. That's pretty good. And let's see. Okay. Tick per resource. Let's see, unsign in tick. Maybe we just want a pointer here. Let's just do extractor, storage, extractor, tick per resource. Uh, okay, so this is actually overlapping. Let's see, ImGUI, C layer. Maybe I want to actually create it with the focus flag then. There we go. I think it should be on top then, right? Yeah. Okay. Okay. Let's see. So that's a panel for that. It's not very pretty, but it will do its work. Okay. Let's see. In release mode, how are we doing? Pretty good, right? Yeah. Pretty good. How you doing? How are you doing? I'm pretty good, just a bit tired, but other than that, I'm pretty fine. What are you up to? Oh, is it nice? So we actually did this. Let's create a little checkbox here. Or rather check. Oh, that's sad. But I guess an alpha version would be expected to have some problems. Okay. I'll do a small coffee break here. Just chill out. So I'm probably gonna either create the resource processing, which is pretty simple. It's just uh, some simple tickable math that is going to be run every tick. Um, so yeah, the more complicated thing would probably be the conveyor belts. Um, but I do want to create some more buildings. But it would be fun to create conveyor belts. It would be fun to create them because they're a tricky problem. They're a real tricky problem. Especially in terms of handling parallelization. Right now we're not spending a lot of time on our, what do you call it, gameplay loop. And right now we're not even waiting on the GPU, but if I disable the validation layer in the renderer, I think we would see our frame time values change quite a bit. So let's just compare this screenshot here with, let's see, let's expand for something else here. So if I disable the validation layer here, we should see our values change because we will spend more time waiting for the, not only does our frame rate go significantly up, but right now we're waiting a lot more for the GPU. So let's see, if we compare these side by side, to the left is the one without the debug layer. So our front-end compilations is not even traceable in milliseconds, but our wait GPU is almost 1/3 of a millisecond, where with the validation enabled, we're never waiting for the GPU. As you can see, our CPU spends a lot more time actually doing our render pass draw calls if it has to validate them all. And right now, without the validation, it's really fast to do these command list compilations. But in general, we could reduce this part here by creating less work for the GPU by doing a C prepass, a GPU frustum calling with indirect drawing as well. This would even eliminate even more of the CPU work itself. Basically, we would probably just do post effects stuff, and maybe not bother doing some. Yeah, probably we would still do the debug primitive calls on the CPU side, because we wouldn't be kind of like shipping that in a final version. And then we're doing a bit of waiting on the execute, and the the percent itself. So those 0.8 milliseconds for execute percent, coupled with the wait, is almost all of the backend calls in total. And as you can see, our backend calls is approximately what 95, maybe 98% of our total frame time, and that means that we're basically in non-debug mode waiting for the GPU. So in order to achieve an even better frame rate, uh, since we can do game logic in between all of these waits here, we don't need to adjust the simulation or the actual application layer. We're single-threaded right now, so we would need to optimize the way the GPU is doing work. Yeah, so potentially with a C prepass, maybe we would add another 25% performance. I don't know, maybe. Yeah, so right now these frame times here is all due to the validation layer, and can't be really trusted. I'm contemplating creating a configuration here. Let's do maybe runtime. I'm not sure I should do this right now. I don't trust Visual Studio, so if I break something, yeah, yeah, I'm not gonna risk it. Right now at least. So yeah, we of course run with our debug validation layer enabled. Um, anyway, let me just grab some coffee and then let's look into a building that processes our iron. So what should we do? Should we do? Oh, let's just do the iron processing plant. It's fairly fast to do. I would think because what we want is not in our builder system right now, but inside our data store here, I think. Let's close the core for now. Let's see. Just a sec. So we should of course create a building type here. Iron processor. Okay, I'm almost ready with my coffee here. It's a bit strong. Okay, so let's see. Tile map model, standard box. Let's create a building with the iron processor. And let's do standard box here. And we have special flags. No, that's texture ID, I think. The materials. Smooth materials, I'm not sure. The iron extractor. Let's create another let's see, building standard building material. Let's not create something too shiny, but so that's the sixth one. Okay. Let's create that, and in our builder system, update build tool, GUI and stuff like that. Let's see. ImGUI, same line. Iron processor. That's fine for now. Let's do 0. Okay. Okay. 0. Okay. Okay. Oh, maybe it's the oh, I don't know the mesh ID actually. Oh, yeah. Maybe we should couple this somewhere. Yeah. Okay. Mm, and of course, we do not have any processing of where we are allowed to build this building. I mean, yeah, so this should actually be accessible. Let's see. Yeah, the draw params themselves. We could basically maybe, I don't know. Right now it's fine. It's a bit verbose, but we could collapse it into something else. Okay. Let's just add a case here where we do let's order them though. 0, 1, 4. So now we can build it everywhere we want. Let's do a well, the test box. Let's create a new model then. Do we even create it with an offset? No, I don't think so. I'm pretty sure. I mean, let's see. ImGUI on ramp. Okay. Well, yeah, so it should be UV wrapping. It's not UV wrapping correctly though, is it? I'm pretty sure it doesn't. It should scale it. Okay, let's check our test box. Well, why is the UV so weird? Okay. Okay, let's modify this then on the C 0.5 one. Let's just export that. Test box here. And let's see. Yeah, there we go. Yeah, the UVs for the old one were messed up. How are you doing? Okay, let's rotate it just for good measure. Doesn't really matter, but let's do it. And let's just, of course, add the texture. And let's add some shading here, texture. Let's see, minus 90. Let's see, Can I do something like image or UV? Okay. Let's do all rotate minus 90 scale. Scale on the X. Well, that's not good. Rotate maybe 128. There we go. Scale, scale X. There we go. It's not really that it matters, but I just like this being scale X. There we go. And this is fine. Okay. Let's see. So, okay. And our thingy here. Yeah. Hi there, YouTube. How you doing? Bad sampling. Anyway, right now we can't click it for some reason. Like we could click this one. We can't click it. Oh, it's because we don't have any tile updating logic yet. Let's see. Building type and processor. Hi there. How you doing, buddy? Whoops. So unknown building. That's fine. Then we would do something like an iron extractor, and then uh, um, I'm doing pretty good. I'm doing pretty good. So did you get your uh, what do you call it? Voxel. Uh, I've added um, a function where if you click a building, it will show some information about the building. Let me, for instance, it will show stats about the building. Also, I'm working on creating a iron processing plant here, and then I'll probably do some conveyor belts where you can transfer the iron out of the extractor and into the processor, and then the processor handles the iron. Also, I've added some debugging stuff here. So yeah, some different small stuff. Oh, cool. Did you manage to merge the voxels or the things that you wanted to do in terms of adding backface culling when you're inside a chunk? Oh, that's cool. That's pretty cool, man. So I guess I should do something like this. But for the iron processor, and maybe we would want some kind of like recipe or something. Let's try adding a yeah. Things have definitely been picking off a bit. Um, but it seems like it's coming in waves. Some days, uh, a lot of people join the channel, and then a couple of days go by and no one joins the channel. So, yeah, ups and downs. Occasionally, someone leaves the channel. But I think it's all right. Okay, let's create a new class here where we will do a recipe data store. Okay, let's create that. Let's do a namespace in here. So I imagine the recipe data store here being able to uh, just store some data. Um, so what should a recipe consist of? I guess it's a series of inputs, I guess. All right, buddy. But thanks for tuning in, and always nice to have you here. Looking forward to more updates. And good luck with your stuff as well. Okay, a recipe. How to define a recipe? Maybe the naive way is to maybe we want something like a recipe one just so basically a building that needs to process a recipe. We have the building item storage. That could be item type 1, amount, then type 2 plus amount 2, etc. Then we have the recipe as some kind of like filter that is actually uh, I mean, the recipe itself shouldn't actually. Is the recipe just a series of ratios? Let's see. Yeah, so a recipe, does it even need to be dynamic? Do we even need a dynamic one? Do we even need a recipe system? I guess if you wanted to do something like a bit of modding or something, that it would be more preferable to actually have a recipe system. Um, yeah, I guess we would want to be able to at least adjust the ratio. Yeah, okay. But the recipe doesn't know about the underlying types. The building should only have a recipe added. The recipe should just be a ratio, right? So a recipe should have um, let's do maybe input, recipe inputs, maybe recipe input amounts, recipe output amounts, I guess. I don't know. Um, okay, let's just do this in the most dynamic way, and then we can always revise it. Okay, recipe input will simply be a vector of unsigned int part values, part amounts, and a recipe output will be the same vector unsigned int part outputs, and then a recipe uh, what do you call it, tick our processing time, a float value seconds. This could be the way that we could create a recipe. So a recipe is simply a list of parts with specified amounts. And Yeah. What are you gonna program or create with your project? So I imagine the whole processing flow here being something like building, accumulate recipe time, or rather, maybe even consume resource. No, let's see. We could be in two states here. Okay, we can actually be in a state. So buildings can now be in a state. This adds some complexity to our processing because we want to do something different depending on. Yeah, so we can either be waiting for the threshold of our recipe to be crossed in terms of starting a production. We can be within a production cycle, accumulating ticks for the recipe to be done. That's basically it, right? If there are not enough resources, we're waiting. Otherwise, we should be processing. And within this, when we are done, we reset the cycle timer and either repeat or wait. And it's probably not worthwhile checking this all the time. So maybe it is. We could check every one of these. We could also potentially optimize with an active, inactive, sleep, wake message system. Output to a value, two values, output resource rather. Okay. Yeah. And the recipe itself is just for all input types. Check if value sufficient. Maybe even start out by I think this should okay. Okay, so let's do this first. So if we are in a production cycle, we accumulate the ticks. If we are done, then we output, and then we uh, add the building to an update queue. Is that it? And then we, for all in the update queue, do you think that collision physics is possible if combining two calling vectors from 2D planes? I'm not sure I understand your question, buddy. I'm not sure what you mean. I'm sorry. Yeah. This should be something like... We could also just create it like... Uh, we could also just create a series of condition tables. So for instance, flags. Uh, um, we could do flag parsing and then multiply the accumulation value here by 1 if the flag is not correctly set. Then we wouldn't do any branching. So for instance, we could do something like we could do a condition table has enough resource of XYZ already producing. That would be accumulation times 1, otherwise 0. And then we would of course compile the condition table, check the resources, and their amounts compared to the maybe just try to subtract the resources and then check, then compare to 0, set flag. Um, Then if the accumulation above threshold, message output resources consume next resource. No. Let's see, in our builder system here, no, not building data store, no, that's not the one then. Let's see, in our builder system then, update. We have our resource amount, and we subtract our tick. This is clamped to 0, sort of. Yeah, this is clamped. We want to be able to check like 100 production buildings, and we simply want to check maybe passive. Can we start production? Yes, no. And then yes, consume for those buildings, add to processing queue, or rather list. Then check, let's just do X here, check X, or rather, no, add to temporary production list to be merged with new list. So that's the path. And then we will accumulate ticks for X production buildings, active, over threshold, yes, output resource add to temporary no, let's move it. Let's see, move it. No, add to temporary production list, add to temporary remove passive removal list. Active removal list. No, not necessarily. Okay, so we want to be able to add to a check queue. For next frame, or rather tick. Okay, so add to accumulate temporary. Maybe this doesn't need to be the one that is let's see. Check production cycle. Okay, so maybe a accumulation step is accumulation step, and the check production cycle is just simply a check. We can do that for every building. We can do it for whatever building we want. Uh, add to consume list. No. Okay. And add to a consume list and remove from checklist. Consume resources, apply outputs. So add to output list. Okay. Let's just do a naive approach here. So if we are able to start production, we add to a consume list, remove from checklist, and add to but we don't want to add to consume list. And let's do add to end of tick accumulation list. Okay. Okay. Add to end of tick. Output list. And let's see. Add to end of tick. Let's see. Do we want to? Let's just try doing some add to end of tick production. Check pop list. Maybe we don't want all of these lists here. Maybe we don't want that. Maybe we just want to process all of the data. Let's just try that. Let's see if we need to do some performance stuff. Okay, we could also do something like if we just process everything. every building would have a resource. Uh, I mean, if we set the accumulation value to 0 for each building, nothing will get accumulated. Okay. Check storage versus recipe input. If enough, add to consume queue. Add to tick modifier queue. Apply or compute accumulated ticks. Could be 0. Check accumulated ticks versus recipe time. Okay. Subtract if in a threshold, add to output queue. Add to wait a minute. Yeah, okay, we will only modify the tick, of course, if we actually need to. Add to tick reset queue. Apply changes for frame. Okay, I think this is the way. This is the way. This will give us a a building will have a production building. It will have a recipe type, recipe index. It will have a accumulator. It could potentially have an output. It will have a storage. It will have an output. It could have a max storage. It could have a max output storage. And maybe space. Yeah, this should be blazingly fast. I think the most complicated step here is this one. Yeah, this should be fine. So this is the components. Should we just go all in and do... No, I think I'll do it by structs. Yeah, like this is your general idea. Okay, I'm gonna do a bathroom break. Be right back. Okay. Let's try doing something like that. Blah, blah, blah. Let's do a input amounts. Output amounts. M recipes. Yeah, this is just the old stuff. Okay, let's move this into the building data store here. Yeah, so this will not create a lot of active inactive lists. It will just do comparisons and stuff like that. Okay. Yeah, so let's see. Let's create a struct here. Struct on uh, processor. Okay. Let's see. Unsigned int storage 1. Output 2. Recipe index. Maybe we even want to split this. Maybe max output. Maybe type. Let's do and let's see. Iron processor accumulator. Float tick accumulator. I'm not sure we need the recipe index. Whoops. Okay. Iron extractor. One by one. Iron extractor. Two by two. Let's see, public, generic stuff. Yeah, we could even split this off. Let's see, iron processor. Okay. Let's see. In our application, yeah, instead of placing this on the data store itself, methods. Let's see, G building data store, that is. All right. Okay. And the application here will simply that's way better. Makes more sense. Let's do methods. Whoops. Extern the recipe data store. Okay, let's see. I guess this is fine. We could arrange this in a different way. Ion extractors. This should be fine still to do up here, right? Mm. Let's do ion extractors. Let's do whatever cleanup we, yeah. Right now we are running, aren't we? Let's see. Where's the error? Oh, that of course needs to be afterwards. There we go. Okay. And let's run it in debug mode just to make sure that we do not violate any asserts. Oh, these are going to take too long. Yeah, I'm not going to bother with that. Looks fine. We didn't change anything, so we just moved some stuff, so everything should be fine still. Okay. Okay. So we have our, I mean, I could remove this. Let's see, create tile set. Let's see. Methods. Let's just remove this. Oh. Tile, draw, data. Let's remove this. Okay, let's clean up our code here a bit. Get tile data. I'm pretty sure I'm not using this for anything. Let's see. Set tile params. Tile draw data. Mesh index, standard mesh. Material index, material. Texture index. Y offset. And we could even move this so that everything is in order. There we go. There we go. Okay, so that's great. We fixed the tile data store. Let's do resource data store. building data store. Let's remove these. And right now we will keep this, and then we will just fix the problems. Draw data. Draw params here. Yeah. Instead, let's do a const reference here. Const reference. Well, okay. Let's see, does this still run? Yeah, we're still running, we're still running, we're still running. Stuff. So I cleaned up that. Okay, let's implement the stuff here with the recipe. Let's see. And let's do void create recipe. Uh, mm, Input amount. Unsigned int. Output amount. Tick times. Let's create that. Let's do a recipe. Recipe. Let's see, output amounts, tick times. Let's see. G recipe data store, recipes, in place spec, recipe. Maybe even just like this. Yeah, let's just do that. Okay. Maybe even a name, just in order to be able to debug. Std string name. Let's do a std string name. There we go. And let's ask our application to create some resources. Now this will actually include our recipes, recipe data store here. Let's recipes, create a recipe, iron processing recipe. Yeah, you could change this, I guess. Yeah, I don't know. Inputs. Outputs. Ticks. No, not ticks. Actually, this is a mistake, right? We don't want recipe tick times, of course. Yeah, we can still move it. It's fine. Doesn't really matter. Nah, it doesn't do anything. Okay. Mm, and let's do 5. Oh, it needs to be inside here. And processing 1. Inputs. Outputs. Tick. And let's do std string. Can I do that? Maybe I even don't have it. Okay, let's do const char pointer. And let's do std string here. Okay, we create the recipe. Let's see. Yeah. Let's see. Iron processors. Excuse me. Mm-hmm. Uh, okay, our logic was something like let's see. Using namespace recipes recipe recipe equals g recipe data store dot recipes 0. And then building the data store, storage.size here. Let's do const unsigned int iterations. And let's do this. Let's see. Building max building building count rather. And let's do a const iron what's the processor storage here? Storage. Well, this is not gonna work because this is not gonna work. Because I'm probably gonna change it. Okay. Bolding. Let's see. Okay. 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 Are we running? No, not yet. Okay. So let's see. Let's check the storage then. Let's do for unsigned int recipe inputs. Recipe dot input amounts dot size here. Let's do that. And then for we will iterate over all of the inputs. Let's do const storage equals g building data store dot iron processes storage building here, and then we will compare the storage maybe do an assert here, storage storage dot storage ref. Let's see, count of Hi Bob, how you doing? He might have gone. I'm not sure he's here. Okay, let's try running this in debug eventually. Um, it depends on what you mean. I guess if you have differences between how you store variables and check variables and buffer overflows and stuff like that, yeah. then I've noticed some differences when mistakes like that enter the code. But it's rare. Usually it's the other way around. Okay, this is a bit bothersome. Bool not equal false true. So if our recipe, oh, no, this is not, yeah, maybe, I don't want this. Or, I don't want this check here. Okay, let's see. So if we do like an accumulator here, let's do an accumulator value. And let's do acc value. We multiply it by the std max of 0. Oh. Of 0, and then our ref storage I minus recipe inputs I int here. Not recipe inputs, recipe dot input amounts. So if this ever gets below 0, meaning if our storage, yeah, I am. Why shouldn't I? How long what? The stream has been going on for about 4 hours, if that's what you mean. So let's do, well, maybe I've been working on this game here maybe a month or maybe two. Part-time, of course. Okay, let's accumulate the value, and if it's 0, this will be set to 0. Otherwise, so for each input value, we see if there's enough resources in the building. And if only one of them is below 0, meaning that it doesn't have the required amount in the recipe, it will be set to 0. So if we have a if the accumulator value is something over 0, we can actually do whatever we did here. We will add a consume to our consume queue, add to consume queue. Well, this is problematic, of course, because maybe we do want an inactive list. Yeah. Mm, let's see. So yeah, there's a problem here in terms of handling. I mean, this tries to consume um, hmm. So this is so far this is fine for kind of like starting buildings. So we don't want this to happen if we're in a production cycle. Maybe we just want one queue, right? Maybe we just want a state value here. Yeah, maybe we just want a state value here. Okay, let's try that. Let's try that just for fun. Uh, maybe we want. Um, yeah, maybe let's add a kind of like yeah, maybe it doesn't need to be inside the. Let's just try creating a component that is the iron processor state. State iron processor state processor states. And let's see. Let's compute a state. And the accumulated value, which will be 0 or our total consumption. Let's see. So if we have something that is over 0 here, we could create a transient state here. So one part of the state is, is it ready? So basically we are handling these two flags. Is it ready to consume? Is it already consuming, producing? Um, Maybe we want something like this. If so, maybe we just want to add a transient buffer here. Let's do a struct temporary, and let's do a vector here temporary. Flags or states. High, unsigned and low. States push back, rather in-place back 0, 0 here. And then our accumulator value here. And set the other part to 0. This means that our temporary flag here, high part, is set to a value of 0. Then we can do some processing. So then we want to okay. Let's see. Fastest way. Hmm. Let's see, let's see, let's see. Mm-hmm. Okay. So if we process our accumulators here, mm-hmm. Let's see, what am I trying to do here? Maybe this doesn't make any sense, but this should reset the accumulator, right? Maybe that's the cube. But okay. This is not a global tick value, I think. Yeah, I'm not sure this is correct right now. Maybe this should have a underlying tick value. So we could do float tick value like this. Maybe. Yeah, so if we so this is like if account accumulation value above 0 send signal that will either start production or do nothing. um, uh, so if we have a blah blah blah, we will. How do we decide? Let's say int acc value. Okay, let's do this state. Okay, we add this to the temporary. And then I'm pretty sure the accumulator here should be float tick value. Let's try that at least. Then maybe even maybe we want this component instead. Huh. So if we actually enter this state and we do not have a tick value, we're in the start phase. Otherwise, we're ready for the next start phase, but shouldn't do anything. Maybe that's the way, I mean, this is basically signals. These are messages. Huh. We could also do some control flow. Okay, let's do something else instead. Let's do something else instead then. Let's do the state again. Unsigned int state. Can I do an enum state? Default. Okay. Let's see. Okay. Let's simply start out by creating something like this. If ref dot let's see. Mm, transient idles. Uh, this is more readable. Okay, so if we're idling, we do this. Otherwise, we're processing. Transient processes processing. Okay. Let's see, and then for all our transient idle size. There we go. Yeah, so for all in idle states, we will do unsigned int transient start process. If the accumulator value here maybe we don't want this actually. Maybe we just want accumulator values. Rather transient uh, storage values. Yield factor. Transient yields. And let's add our yield factor here. Okay. And this could easily be collapsed, or rather somewhat unrolled, I think. Okay. So we do some yield factors. And then we will change states depending on whatever we do here. So we will consume these. All right, and then okay, we create some work lists here. Maybe the recipe itself should have something like... No. Let's increase all of the tick thingies. And then we will check them all. Let's see. Well, I'm not sure. This is a float. And then let's see. Okay, transient. Produce. Let's see. Constant sign in index. Okay. So right now our workflow is, if we're idling, we add to the idle list. Otherwise we do to our processing. If we add our yields for all our idles for later processing, so we need to process yields, and change states where needed. Then we need to process let's see. Yeah, I would rather do this in one step. Um, process production output. Okay, is that what we need to do? So we have we sort our stuff depending on let's just do unsigned int here. Unsigned int. Let's do unsigned int and simply cast this one. Okay, so we have some yield factors for our idle ones. We process some yields. This could either be 0 or it could be something greater than 0. If it's something greater than 0, we will have to enter a production state. We will process the yields down here. Then for all of our transient processing states, we accumulate ticks. And this will allow us to actually have recipes that have half tick cycles, or yeah, yeah, we can adjust ticks accordingly since it's floats, and we can keep the decimal, the remainder. So we accumulate a tick. We add one tick here. Then we check if we are. This should not be called tick times. It should be called tick threshold. And let's see. Okay. We will have a tick threshold. And if we are above that threshold, we know that we have to consume for this building here, which will be down here. So let's see. Let's process our yields then. Let's see, building, listen, transient, yields, the size, building plus plus. if we're actually having a yield here, let's see, 0 is idle, 1 is producing, and this can only come from a idle building. So if the yield is anything, we can update. Let's see, do we actually have transient yields? We don't have the underlying index. Let's see, maybe transient idles. Oh, that does have the indices. So if we do transient idles, because this will be a mirror of whatever list we have there. So transient idles, let's do a const unsigned int here. Index equals transient idles building here. And then well, these lists will be mirrored, so maybe I don't need to do this. Yeah, maybe I don't need to do this. They will always be mirrored. Yeah, so I can always look up the index like this. Okay. So if we do have a maybe I don't want to access this unless we have an actual yield here. Okay, if we have a yield, let's do ion processor state ref g building data store ion processor states. Let's see, index ref state equals let's see, ion processor state processing. So we will update our states. We will for the same buffers here simply do something like this, although we will do it yeah, maybe this is better. And let's update the recipes here. And let's do ref I subtract storage I subtract the recipe input amount. This will consume the resources. No, this should actually be something else. Yeah, so this should be something like std vector transient consume. Yeah, sure, in a sec. So this is the game so far. With ion extractors and solar panels and stuff like that. And you can see here from this simulation that we extract some resources and yeah, this is what's going on so far. Maybe we just want to do like transient consume the index here. Because if we have yields, we could consume and set states. Yeah, let's do that instead. Transient consume. Yeah, and if we used a different structure than a vector, we could actually, what do you call it, make small alterations to the way that the memory is manipulated so that it would probably get faster. Okay, so we check our state. If we're idling, we add to transient idle lists, and if we're processing, we do that, or otherwise we do that. Also, let's see, let's add the recipe up here. Then we check if we have a or calculate a yield factor. It will be 0 or it will be above 0 depending on if we meet the requirements. We do not do any branching here or any checks. Then we accumulate ticks. Then we check our tick values and add to a production list if we actually surpass the threshold. Then we check our yields. Are they actually bigger than 0? If they are, we prepare to consume. During our consumption step here, we want a reference to the storage of the building, and of course we do an assert whether we can actually iterate over it. We consume our storage, and we should also set ref store, because we also want to set our let's see, our processor state here to our state. Let's set our ref state here, state to and processor state. Processing. And then we actually have consumed our yield. We've updated our data storage. And then we're ready to process our output. Transient produce is the vector. So let's see, transient produce here. And let's see, transient produce. It's also indices. So if we produce we want to update our stuff here. So let's do const unsigned index transient produce building. Okay, and then iron processor state ref state. Let's see, iron processor output ref output. Ion processor output. And let's do a tick as well, accumulator. Okay. Let's see. let's see, recipe inputs, recipe outputs. And then plus the yeah. And okay. And we're done, right? Let's add a struct here. Let's do struct iron processor transient data. Iron processors. Oh, I already have that. Iron processor data. Transient iron processor data. Okay. Let's do transient data. Not transient processor data, transient iron processor data. Transient data. Clear. Transient idles. Transient processing. Transient produce. And transient yields. Let's do const unsigned int index like this, and then transient data, and let's do the same thing here. Okay, and we're compiling, right? Seems like it. Okay, let's try adding a iron processor then. Because now I think we have most of the logic. Yeah, so let's try doing that and see how many problems I haven't anticipated. So let's see. Create and get building subarray index. Okay, let's implement the iron processor then. Whoops. Let's just do a simple test right here. Created. DXE call print, of course. Okay. Let's see, output. So we have state accumulators and stuff like that. And let's do a check whether we actually run this. Okay. So let's just do gxe core print here. Ran. To see if we actually go through the loop. Did we have a crash now? Yeah, it seems like it. Great. I don't know why. Probably some weird interaction with yeah. So it runs for every tick. So it actually runs. That's pretty great. Okay. Ran tick. On index building here. And then ran accumulate on index. Let's see. Ran consume on index, and then ran produce on index. Yeah, right now we aren't actually building anything. Okay, so in our create panel here, let's do a ion processor one. Break. Ion processor. Let's see. And let's grab the storage here. Let's grab the output. Let's grab the accumulator. Here we go. So let's do something like iron content is probably fine. Let's do storage here. All right. Oh, whoops. Storage. Whoops, that's the state. Storage. Storage.storage. Great stuff. Output. Accumulator. Plate content. Output. And then state, of course. Let's just do tick. There we go. Let's see if that for one compiles and runs. Yeah, so we're in the 0 state. We have an iron content of 0, and we have a plate content of 0. So whenever we create our building, let's just hack in some values. Let's see, state, that's fine. Let's add maybe 100 iron plates here. Let's see if we crash on this. We can't do that. Okay, let's see. Unsigned int storage. Like this, right? No? Let's see. Okay. Storage. Storage. Okay. Tick accumulation. And immediately we have a producing building. And it simply just works. That's awesome, man. The code just works. So if it has any iron content, it will consume it. And then, oh, there's a bug then. It seems, okay, yeah, running ticker on index 0. Okay, so it's not perfect yet. Okay. Let's see the recipe. What do we actually... Okay. So we take 10 iron plates and produce, or rather 10 iron ore and produce one. Let's take threshold. Let's do 1.5 here and test with an uneven tick. Yeah, so the last part here. Oh, I think why. I know why. because in the yield, it will turn out to be 0. So if we just, in our processing loop here, okay, if this is exactly 0, we won't consume the last one. Okay, this is problematic. Yeah, because if this is 0, so let's say that our requirement is 1, our data storage is 1, and we want to return a 1. So if we add 1 here, if the storage is 1 and the input amount required is 1, then we will end up at 0. So if we add 1, we will actually consume. If not, if not, if our storage is 0, but our requirement is 1, we would end up at 0. So I think we could add 1 here and then be good, because if it matches exactly, we will end up at 1. If it's overflowing, for instance, if this is 1 and this is 2, we would subtract 2 from 1. That would give us -1 plus 1, that's 0. Yeah, so this should make us do the last tick. Okay, so if we place this building, we immediately see that we tick, we consume the iron ore in it and create iron plates. And we consume the last one and then output the thing whenever the tick is done. Okay, so let's create the iron recipe. Let's see how many ticks would we want our iron recipe to take. Maybe 10 ticks. And we want to consume 10 iron ore and produce 5 iron plate. And we right now create our processing plant with a storage of 100. Let's just do 1, 2, 3. Alright, so let's say we place our building, we accumulate the ticks. Okay, we produce the first plates. Yeah, and when programming this, we should remember that the state takes 1 tick to change. So in order to do a certain production per second, you would have to like subtract the initial tick, because when we consume, we add to the queue and have to start, right? $60. So basically we should have it, and then we should end up at the remainder. So I think 60 is the correct result. Yeah, it tries to run the tick itself still, but it really can't because there's no more resources. Well, that's basically a bad state. So if there's a remainder, okay. So this is basically a bad state, I think. Ran produce on index 0. Do I not set this state to? I should be setting this state, if I remember correctly. Ran produce. This state should be idle. Ref state. Um, oh, did I have tick as the output value? I didn't see actually. Yeah, we run, oh, yeah, tick is the base one. Accumulate is the actual production. Okay, I think it's good. Let's speed up the tick step, or rather threshold here, just to consume stuff faster. Yeah, now it doesn't output anything, so it's in the right state. It was just bad output in the log. Okay. Let's see, let's create 2 of them then, just to check that everything is working. So let's add this one here, and then all right, it still works. And we don't really see it even in our runtime here. So yeah, it doesn't even affect our game logic step. So it's quite efficient, quite efficient. It's very data driven. That's pretty cool. That's pretty cool, man. So we actually have an ion electrolyzer, sort of. Um, So this game system is done. We have recipes with input amounts and thresholds and blah blah blah. So we can add a recipe like this whenever we create our simulation processing for our um, buildings. We of course need to specify a recipe here, and everything will be handled automatically. I guess we should try adding a, well, I don't know. Could I do something like, because it's compile time, let's see. Can I do something like, uh, then do for in I less than I plus plus. Let's see, and then let's see if this runs. I'm not sure. Oh, it does. Huh? Output. Why do you even ask? Okay, does it actually have several outputs? Yeah, it does. Oh, oh, that's interesting. Yeah, so do we actually have an assert violation here? Yeah, we do. Ah, interesting. Yeah, so at least we get an assert whenever our recipe doesn't match our output. Okay, so let's see. Ein processor output 2, and let's do a recipe here. And let's see, maybe 1 here. Yeah, and immediately we have a working recipe. Uh, Great stuff. Okay, so we can actually output 2 resources from our iron processor here, which is great because this recipe here is supposed to create pure iron. This recipe is supposed to produce pure iron, and of course some oxygen. Pure iron, oxygen. And it consumes, and it consumes, and it consumes, and it consumes. And it just keeps on chugging. So now we are actually ready to create maybe a series of conveyor belts that will take our iron, unprocessed iron, and load it into our iron processing plant number 1. And that will probably be a challenge. I mean, it was a challenge figuring out how to arrange the whole processing loop, but when it just worked first try, almost, with only one minor adjustment, it feels so good. And it's really efficient. No cache flushes um, or rather cache evictions, something that is highly scalable. We can replace a lot of this code with SIMD AVX 512 instructions. So we can do this blazingly fast. And we basically have a way of handling null states as well, all through the pipeline. So that's great. Okay, so I'm gonna probably do a break of sorts. Grab something to eat. Since I've been going at this for 6 hours and I think I've made good progress. Maybe we want a bit of fiddling around with the color of the Let's do maybe a red texture. And we could of course do something more um, beautiful if you uh, yeah, something more beautiful, like we could do ImGUI. Mm, so let's do something like ImGUI, same line. If we do something like this, maybe even a another color here. Okay, let's not actually output this state, or rather, maybe we just want the debug information. Okay. What's the yeah, it's a bit of additional processing. Doesn't really matter. Whoops. Let's move this back. We don't want this highlight anyway. All right. Okay, let's set up a break screen. So if let's see, if I do coffee break here. Let's see, this is the game dump. Okay, so if I do like this, and let's do it text. Okay, let's see. All right. I'll be back. Yeah, I definitely want to fix that. All right. Catch you later. Alright, if you don't mind me eating, I'll talk a bit in between, but so I'm thinking about this whole conveyor belt thing, and I think it's something about like you have to create some paths and merge different paths. Um, yeah, so, mm, how to do that? And then we swap back this stuff. Mm, mhm. Um, so yeah. So in order to do a conveyor belt, we need some serializable path where you store, if you look into the factorial, like this. Mm, mm. So we're going to read this article here and figure out how to do some belts. Let me just grab some more to eat. Yeah, so Let me just read this stuff here. Mm-hmm. Mm-hmm. Um, mm, okay. Um, mm, so this is actually uh, okay. So they basically create an array with items, which is like then the build segment starts with an offset in until the first of the items. Okay. Let's see, so in order to do something like this, okay. Well, when we're so basically, if you want to render it, uh, so let's see. So okay, so in an unblocked build, okay, so in order to do this, we should probably, okay, we will do a naive implementation. Okay. Okay, let's start building some stuff that can be used as an conveyor belt of sorts. Okay, let's create another building type here. Let's see, building type conveyor belt. Isn't that correct? Yeah. Let's see, create building params, conveyor belt. And let's do the actually tile model here. Okay. And let's create a slot here in the build tool. Whoops. Build conveyor belt. Right now we scale down to 0 or 0.5. Building type. Okay. Let's see how that works. That's not too bad. But it should have some kind of Y offset. Is it like something like this? Well, that's too much. Maybe 1 or 0.5. And then okay. Okay, let's do one direction. Okay, so we will do it, well, let's see. Does it actually intersect? No, it doesn't. Let me just... Okay, let me change the whole scale stuff. Let's see. I don't use the scale or what? Model scale. Oh, I do. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. Scale X. Let's set it to the PCH. XM float 3. Scale. Okay, and let's still have that method. Building. There we go. And let's create a version of this one where we actually pass in a XM float here. There we go. Then we create a version that actually allows us to specify yeah, and let's fix the let's see. Position, blah blah blah. But it should. Oh, it's because it's okay. I'm trying to convince it to do something that it absolutely won't, and I see that I am mistaken. There we go. Let's see. Okay. Let's do our build system here then and check if build is allowed. And let's add a case building type. conveyor belt. Okay, this is our magnificent conveyor belt. Let's see if we can find a more interesting texture, perhaps. Blue, so that's 9. Let's try that. Huh. Well, oh, this is the material. Whoops. Okay. How does it actually draw it? I can't remember. So buildings? All right. The actual position and fundamentals of the building is stored outside the actual logic. That's why it's so easy just adding stuff to the build system, at least in regards to that. Okay, so we could create the game with actually some what do you call it? Conveyor belts. So let's see. Our draw or rather build call is create building, and then just this. So I don't know what this is. Oh, it's the old stuff from the simulation window. This is fine. Let's keep that one. Let's dump this. Okay, let's move this whenever we create our world here. Um, Whoops. Build a system. And let's do a small for loop. In column 0 and then column less than 5 columns and C++. No pun intended. Let's do int x plus start, int c plus start. Plus c. builder system buildings. There we go. This should create our buildings. Okay, we don't want them there. Okay. Let's create a temporary function. Temporary methods. Whoops. Let's do void. Do test setups. Setup. Local methods. Start of global methods. Okay, so in our building data store, let's create hardcode a how many? 1, 2, 3, 4, 5. Struct, conveyor, build segment. Let's see. Items. Conveyor, build segments. Currently testing. Conveyor build. Conveyor segments. Okay. And maybe we should create G building data store. No. Yeah, G building data store. It's conveyor belt segments. Let's in place back one conveyor belt segment. Segment. And in our application, let's make sure that we actually do this. Do test setup here. Okay, this will create it. And then maybe I don't know. Are you supposed to like store their indices or their type? Maybe we just want to store their type. But we might also want their index. Uh, type. An array of items here. Okay, let's create a bit longer build. We will do this manually in order to define game test conveyor length. And let's do 8 here. Let's see, PCH. System values here. Okay. So this should be able to create a an array of items for our conveyor belt setup. And let's see. So the idea is that I should probably be able to click a button somewhere. Maybe even in the application. Whoops. Let's see. Testing stuff. ImGUI begin. Temp window. ImGUI end. And then a button if ImGUI button add item to conveyor. And then our builder system building g building data store dot conveyor segment 0 items Let's see, game test. Yeah, we would have to generate, right, this stuff for rendering. Okay, let's maybe do something like this. Okay. Okay. Let's try rendering items on belts. And let's do a const std vector buildings conveyor belt segment belt segments. Okay. Then for oh, I'm messing up all everywhere. Can't even write a simple for loop. Must be an idiot. Okay, so let's grab our const reference here. Segment. Whoops. Okay, we have our segment. Let's check. Let's do some naive code here. It's not gonna be optimal, but right now we're just trying to get some debugging information to the screen. So if the segment items, oh, then let's iterate over int item game test conveyor belt length item plus plus. This is definitely not production quality code, but I just want to see it, what's going on. If the item itself should be segment, let's see, constant sign int index, maybe just int equals segment dot items item dot index. If index is larger than 0, let's draw something. It shouldn't cast a shadow, I think. But maybe it should. I don't know. Let's see. Let's do the third parameter here and just the first material, first texture. And let's do the flex here. Flex. Let's cast the shadow at the beginning at least. Oh, this is going to be really hacky. Because I'm just gonna start out by using these values here. And let's see. Let's do high code with K. What do you mean? What about others? What does that actually mean? Do you mean like other APIs or? Let's see. Load scale. I can't give you a roadmap for Vulkan. I haven't. Oh, so, okay. So immediately we spawn this one. Okay. Well, do DirectX 11. Do some tutorials on that and get good at it. And then when you have a fairly good grasp of that, try to migrate into DirectX 12, and then you will also eventually understand Vulkan. At least that's my suggestion, but I don't know. Let's see. So this should be our test box, right? So if I press this, yeah, I spawn a box and it does cast a shadow. Hello. Yeah, well, that would make you able to do graphics stuff. So if you build something in DirectX 11 and then when it's operational and you try to port it to DirectX 12, you will automatically learn Vulkan because it's a low-level API, which basically is just instructions to the graphics card driver to do different stuff, and most graphics card drivers lead to a highly similar API. So I understand a lot of Vulkan, even though I've never done anything in it, because it's basically just telling the GPU what to do. So start out by doing a DirectX11. Hi, Ankit. How are you doing? If you don't want to go the ordinary route with just learning OpenGL. I think learning OpenGL is a great solution. I would actually do that if I were to start over. But now I'm working in DirectX 12 and it's all right. Okay. Almost there. Almost there. It doesn't have to touch, but right. So we spawn an item here. So if we look at the Factorio article here, yeah, OpenGL is great for beginners. It's fantastic because you don't need to understand in detail what the graphics card does, but you do need to understand graphics programming. So that's why it's so great for beginners, because it's not too complicated and you don't have to worry about synchronization and different memory allocation strategies and um, different resource states and stuff like that. The driver just does it for you. So that's why DirectX and Vulkan is so verbose and uh, what do you call it? Cumbersome to get started with, because you have to manage everything yourself, almost at least. Okay, so we add this item here. And then in order to do something like this, we obviously need to track the distance between the item. Okay. Yeah, and Kit, I think so, but it depends on what you find fun. Maybe you would find working in an engine more fun, or maybe you just prefer to play games. So, okay. Let's create a section of the update step here for all our buildings. So we have our iron extractors, we have our iron processors. Let's add a section here, conveyor belts. And once again, I'm gonna just hard code some stuff here. Yeah, I got a great one. Probably one of the best. Go to this one. It's fantastic. You can even use it if you decide to do DirectX 11 or something, because it's graphics programming. So it's fantastic, I must say. Okay, so we have our building here. So we're not gonna manipulate the array itself yet. So our conveyor belt should be something like do they perhaps do it more granularly? So I mean the objects are kind of like let's see. Okay, so we could store the item gap itself. I don't know. Yeah. Yeah, so if we store a gap between each item, yeah. Okay, so it seems like we have a uint exit. No. Let's do a float exit gap, and let's do a float entry gap. Let's do a float gap next. Okay, let's see. And then let's do an unsigned index. Yeah, sure, buddy. I know that feeling. Distance index. Yeah. Of course, send it on Discord. So the idea here is that we decrement this distance and then start increasing this one. But also we manipulate this distance here. We can index it. Yeah, thank you. Let me check. Oh, it seems like you have maybe a problem with a missing pragma, or I'll just reply to you in text. Maybe missing pragma once, or static, missing static or extern, depending on your definition. Try looking for errors where you end up multiply defining something in the CPP or a header file. Okay, so how are we going to do this? So when we create our item here on our conveyor belt, we got it stored. Let's see. Let's simulate it. Okay, so on our conveyor belt here, whenever this is the recipe stuff. So exit gap is the whole of the conveyor belt, right? So we have conveyor belts that span how much? Uh, let's see. So the radius of this collider here. Can I use that as a distance measure? Object radius 0.5. Yeah, so it should be not yet, but hopefully it will soon. I've created an iron processor here with recipes and different logic. So it consumes iron and then it produces pure iron ore and oxygen. Yeah, so, and I've created a system that allows me to create recipes like this. So I specify a recipe that takes 10 iron ore and outputs 5, what do you call it, pure iron ore and 1 oxygen and it uses one tick. Thank you. So I'm just building the conveyor belt system here in order to actually be able to, couple our extractor to our factory here, or processor, so it gets fed. Okay, so whenever I actually press that button, um, let's add that. And then let's set exit gap is equal to it complains that you've defined something. It whines that you defined something multiple times. So usually that means that there's a header file that has multiple instances of the same inclusion, or that something is missing a pragma once, or that um, yeah, the linker set up something wrong. But usually it's a missing pragma or a PCH complication. Maybe if you've included something where you shouldn't. Okay, so the exit gap here should be computed from this item here. Let's just create the first item here. No, but in header files and in inclusions and so forth, you need to use pragma once. Otherwise, you would get multiple definitions and. But as I don't know your compiler, I don't work on Linux, but um, it seems like it's simply complaining that you uh, okay, yeah, you could do that as well. But it seems like it's whining that you created multiple definitions, so it's related to something a linker include related, I think. Okay, let's see. Let's just add to the first part of the array. And let's calculate the index gap here. So game test conveyor length, total float, total length. Okay. Okay. The total length is this. I know that feeling. I spent the first part of the stream looking for an error I really couldn't understand, and it was a typo. Instead of a C, I put in an X. I think I spent like 45 minutes looking for that, testing different stuff. It's just the way it goes. Never assume you wrote things correctly. Okay, total length -1. Let's just do that. Let's set the exit gap. And let's do the position start calculation. The C position is fine, but so okay. When we create the building, we do edit. No, I haven't added any physics, but I've added a ion processor that takes the input and creates output uh, from a recipe that I create. Here, for instance, this takes 10 iron ore and creates pure iron and oxygen, and it uses 1 tick. So I've created these buildings that process this iron, and now I'm working on a conveyor belt that is going to push this uh, object here. Maybe I should. Okay, so this is just to create the visuals. This has nothing to do with the actual logic. So let's just temporarily add this. Xpos end, cpos end, and we did. Can I do actually? Yeah, I can make the compiler evaluate it for me. So right now we will get our end position for this conveyor belt. It does? What's Minecraft Live? I don't know. Okay. Oh. So we will iterate over them and then create the positions. So let's see. Whoops. Let's see. Segment. Segment. Please, buddy. Don't whine. Okay, let's see. No, okay. But sure thing, buddy. Okay. It obviously didn't work. Let's see. Maybe it's not set correctly. Did I mess some value up? Okay. NPOS. Am I not allowed to do this? Oh well. Somewhere it doesn't get stored. Maybe. Oh yeah. Okay. It's probably set to 0. When we call the test stuff. Not here. Segment. X pos end. Segment. Set pos end. I think this creates 0 values on every slot. No, that's not it. Whoops. Okay, let's enter the debug mode. And let's see. So 15. Am I? Whoops. Oh, there you go. So it was getting created. Yeah, so 0, but Only 50%? Let's see. Whoops. Let's see. Belt segment. Segment. XPOS end is 11. That's quite big. Um, yeah, maybe it's a wrong call or a wrong template. So I mean, this is the x equals 3, and this is 0, 1, 2, 3, 4, 5, 6, 7. So the C should be 7. Oh, I shouldn't add to the C, of course. That's silly. Uh, okay, does it creates it and then -1 to offset into x, right? Okay. Or is it? I don't know. So this will be 11, 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that makes sense. This is correct. Okay. Why did you? How did you fix it? Okay. And let's try subtracting the segment. Exit gap. And we're back to the start. Yeah, definitely I need to be able to rotate. I'll rotate later. Processing the but we already have rotation. It's I have object rotation implemented. Uh, so we can easily rotate objects. It's no problem. Okay, so if the exit gap here decreases, we can actually simulate this now. So inside every tick here, exit gap minus equals maybe 5 float. So we immediately have something moving here. And keeps on moving. And let's just do some simple stuff here. Again, the code will be refactored so it's more performant and better. Let's see. So this would of course clamp it. And we could also lerp it. But right now I want to be able to do this dynamically. So let's create a vector here. Item. Let's do items. Okay. Yeah. We will do that with lerping. Also, um, we want more fine-grained movement. So this is just temporary and getting the logic up and running. So let's see. When we do like this, we will do, let's see, buildings, conveyor belt segment, item, in place spec, item here. Okay. And we won't set the rest of this stuff yet. So oh, sleep well, man. Nice having you here. And yeah, seems like people find it okay what we're doing here. Okay, so we add this. But before, if we have a item already, if we have an item already, no, sorry, it doesn't. We only support Windows and Xbox. I think you need to do Vulkan or OpenGL. Okay, let's see. Well, I don't know. It's because APIs usually interact with drivers, and I don't know. Linux is hard to support, man, because it's so many different things. The kernels and package systems are different across distributions, so I don't think it's easy to maintain or even develop. But I don't know. I don't know nothing about it, so it's just a guess. Let's see back. Well, it doesn't seem like they have to force anyone to buy Windows. Everyone seems to be doing it. Okay, so thank you. Um, so right now, okay, we need to update this as well. Segment, items. Which thumbnail? The one on the stream right here today, or? Okay, so this moves yet again, but so if we add several, it doesn't really work. Oh, it was just my very first DirectX12 project. It's just three boxes with Blin Thong lighting model. It's really simple. I just think the lighting turned out pretty good. I haven't updated it for ages. I probably should, but I can't figure out what to do. Okay, so this should in place back. Does it actually end up replacing? Why does it replace it? It shouldn't. It should just add it. Oh, maybe they all. Oh, they are, of course. They're actually rendering to the same spot. So I do create several ones. They're just overlapping. Of course, of course. So let's see. Whenever we add our item, where did I go? Down here? What? Yeah. Okay. So let's do what I tried to do before. If this has the size of something. Oh, we're close to episode 30. Wow. Um, I have this plan here. So we actually did this. I forgot to put in the check here. So, and then I have this board here with all this stuff here I want to do. So in order to optimize the rendering, I would want to do compute-based indirect draw with a CPass and stuff like that. Yeah, maybe PBR rendering, meshes with or rather models with multiple meshes, and a simple animation system, stuff like that. So there's a lot of stuff to do. I can't really decide yet. But let's see. So well, I'm gonna do it differently than OpenGL. So I'm gonna do it. Let me just show you in Paint here. So uh, I'll do something like compute bounding volumes, just spheres for all objects in a grid chunk area from a BSP tree, and then I'll submit that into a compute shader, which will do the frustum calling, and that frustum calling with the compute shader will create draw calls on the GPU instead of the CPU. And then I will use those to do a C prepass. So this will use a compute shader, which will create the draw calls themselves in terms of what's visible in the frustum calling. Frustum. You could extend this with something like potentially occlusion culling if you wanted to. You could also defer it and do it later. But it will be way faster because it's on the GPU, and it will directly create the actual draw calls, both for the shadow map and so normally you do frustum culling on the CPU, and you simply you eliminate all these CPU side draw calls like this. But with this method, you can just offload it all to the GPU, and it will do it really fast, and it will also create the correct rendering commands. And that's what the methods called Directx12 indirect execute indirect. This is basically something you can couple with a compute shader and create draw commands on the GPU from. So our rendering pipeline will probably change a lot when I implement that. But that's for a future episode, and it's somewhat complicated. Okay, if we have an item already, yeah, it does, but if I close OBS right now, I still have around 2000 frames per second, so This code is pretty well optimized already, but it will definitely get better. Also, then I can start adding PBR, because it will be more heavy on the shader, and I would like a C prepass before I do PBR rendering. Anyway, let me see. Okay, let's see. Flow distance. So we need to compute some distance between this item and the next, or rather previous one. Thank you, buddy. And you're always welcome here. Looking forward to hearing from you again. Let's see. Uh, let's do. I'm not sure whether this should be done like this, but we will do it for now. This is somewhat artificial. Oh no, actually, yeah. So this is. Okay. Let me see, just a sec here. Where does it stop then? It doesn't stop all the way at the end. Uh, so if the exit gap Huh. So we subtract the from the exit gap whenever we create the exit gap. Maybe we just want total length. So it creates it at the start. Uh, let's see. Yeah, so this is, of course, fine. So this is where it starts, but so whenever whoops. Um, let's see. Yeah. Okay, so now we have at least our object lining up correctly. So when the gap is 0, it does get created. So let's see. So they talk about doing it. Okay. Yeah. So let's try doing this. So does the gap follow? I mean, it's item gaps, right? Yeah. Let's see. And of course, if we do something like this, it will be more smooth, I think. Yeah, it's not smooth enough. I'll fix it. So the simulation is not. Yeah, I guess you would want to lerp between frames, right? Problem is though. Anyway, let's focus on the actual gap calculation. So one way to do it is actually um, so the distance, yeah. Do we want to store it on the actual item? Maybe we want something like gaps. Let's do something like that. Let's see. Instead, we store the distance between items. So that's exactly what I'm doing here. And the inter-item things doesn't change a lot. Yeah, instead of updating each item position, we can simply just uh, here. Okay. Let's see, gap index. Oh, this is the distance index. Just do gap index here. Okay. Whenever we need to calculate let's see. So we set the total length. If it's the first item we create it with the exit gap. And then if we do have an item, we need to calculate that item position. Let's do an item reference here. Const item, no, const unsigned in index. Let's see, const unsigned int items -1. No, we actually don't need this. If we actually do have items, we can calculate a distance from the exit gap distance to first item. And then the difference exit gap distance to first item. Okay. Is equal to the total length minus the exit gap, I guess. And let's try adding that. Gaps, gap index, or rather gaps, and place back distance to first item, next item. No, this is only going to work for Let's see if we have. Okay. Instead of doing this, we can just do for and I are for each gap in gaps float accumulated distance. Okay. Accumulated distance plus equals exit gap, right? Uh, okay. Okay. So if we do actually have items, we start filling out some gap stuff. Okay. Okay, right now we don't need to do this check here. Okay. Let's increase the speed. Oh, that's too fast. And of course the no, let's see. Hello, how are you doing? I'm happy to hear, man. I'm building a factory-like game, terraforming game. I'll show you in a sec. I just need to let's see. So yeah, this is a conveyor belt. Uh, whoops. But yeah, I'm building this factory game here with harvesting of resources and resource processing and stuff like that. But yeah, I'm building the conveyor belt logic here. So thank you very much. Thank you very much. Much appreciated. Yeah, I'm using ImGUI. What's OGO? No, I'm using DirectX12. I implement everything myself besides the ImGUI stuff. DirectX12 all the way, baby. Yeah, you'll get used to it if you work in Vulkan or DirectX 12 over some time. It'll make more and more sense, and yeah, it's not that troublesome. But I've been doing it maybe, yeah, I don't know how long, but definitely maybe too long. Nah, not too long, but yeah, more than most. Or rather, no, not more than most, but more than some. Okay. Yeah, oh, that's awesome. I wish I started with DirectX 11, but I didn't. For some reason, I had to do um, what do you call it, DirectX 12 here. Okay, so let's redo this stuff here, where we calculate the position. Right now, we won't affect the C value. Yeah, I did. It was really hard in the beginning, but now I've implemented post effects and a lot of different stuff. So like bloom, this has bloom. You can see the edges maybe are blurry. Uh, I do shadow maps here in DirectX and uh, of course lighting. Uh, yeah, so most stuff I know how to do in DirectX 12. But yeah, I should definitely have started with DirectX 11. That would have been way easier. So no, I'm not trying to make the conveyor belts smoother. I'm trying to implement the movement logic of whatever item is on the belt, and then I'll, of course, smooth the animation itself. It's because right now my simulation only updates uh, uh, with one tick every second, or 60 ticks per second, but my frame rate is like uh, without OBS it's almost 2000, but with OBS it's all 1200 frames per second. So definitely a discrepancy between the um, frame time and the simulation step. But yeah, I'll have to smooth it. But first I need to actually get the logic up and running. Yeah, exactly. So I'm trying to figure out how to offset them. So when this increases to 2, we will have for the first item, it won't matter. Um, I prefer not to branch whole lot here. So sure, but I think it's just because I'm tired. I've been streaming for almost 10 hours. So yeah, rather 9 hours. But basically, the way that the Factoria guys have implemented the movement of items on on belts is that they have this uh, exit gap here, and they have this uh, entry gap here, and then they have an array of distances in between. I'm just trying to make my rendering actually correspond to that. So let's see. Load x start pos is equal to the So so our start position. Yeah, the rendering should probably be decoupled anyway. Uh, yeah, the rendering should probably be computed in a wholly different way because we will also handle curves and stuff like that. Uh, mm, yeah. So, but just as a proof of concept, so this should always, if we have more than one item, we can add the distance. I just really don't want to uh, do a I really don't want to do an if statement in here. Maybe if I just do let's see, float xpos equals x start pos here. And then we could do something simple like listen. Let's see. So if we are at the first item, if item equals 0, yeah, that's true. I'm just totally biased because today I implemented this whole thing for iron processes in one go without testing one thing, and it's just so beautiful. It's perfect. It's literally doing everything it should. So this whole resource processing from the recipe stuff, and yeah, it's so scalable. So, but yeah, I know I'm too tired to implement great code right now, and I should just do a bit of branching here. If we have a series of items, I'll worry about this tomorrow. Let's see. Okay. And let's do xpos plus equals the segment dot gaps item -1. Okay. Let's see. So after I create this, oh, it doesn't work with the next one, I guess. Sad. Okay, it didn't work yet. Now let's add this, not add this. Okay, we should be creating them. Print core, not gore. Gap calculation. Let's see, accumulated distance here. Let's, whoops, move this. I read a lot of blog posts on what you call data-oriented design, and I try to stay away from object-oriented programming. And also, I've built some smaller programs where, oh, the gap calculation is 0. That's why. Oh, of course, yeah. So I do need. Let's see. So this, yeah. So I built some different programs, and you know, learned how to do different stuff. Let's see, total length minus exit gap here. One, 4. Yeah. So if I click this quickly, whoops. If I click this quickly, okay, we create the first item, then 0.5, then 2.5, then 6, 13. Shouldn't be increasing. Oh, I'm so happy to hear that, man. Hopefully they were okay. Uh, I think there are a lot of different stuff. The most complicated stuff is probably like this blog post here, but there are several good ones. Um, but yeah, in general, I try not to do object-oriented programming because uh, I try to map to how the cache and the CPU actually works. Casey Moritori has some pretty good tutorials, or rather courses on that. So the gap should be between. Oh, okay, but I think going with DirectX 11 is pretty great. If I had to start over, I would definitely have done that, knowing what I know now. But yeah, I did a lot of different programs, and at the beginning I did object-oriented programming, and then well, but it's not that it's a problem when you're doing simple applications. It's just that it's so easy to prove that object-oriented programming is bad for performance. It's and if you're building games, it's so important that performance is good. So and if you want to understand why, it's because it doesn't map to the way that the CPU actually works. At least traditional object-oriented programming with inheritance and stuff like that. Basically, you have to structure your data in a way that it optimizes the cache access, and that's very hard to do with big objects. And yeah, okay, we take the exit gap and we set our accumulated distance here. Um, okay, so we try to accumulate whatever gaps we have. But right now we don't have anyone, so this will be 0. So if let's see. Yeah, well, if they can't, if they can't argue with why, it's not. I mean, everything he says is correct. It's easily provable. He does it by showing the performance difference, and he actually has a course where you can learn how to actually write code that maps directly to the CPU and the way it works. And let me just tell you that there's a huge performance difference, like up to 10,000 times of a performance difference. Not always 10,000 times, but maybe 100 times is easily achievable. And um, even though you might not like it, uh, uh, or even you might not care, it's still true. So object-oriented programming is perfectly fine. You can do whatever you want. No one really cares. But once you need performance critical applications, uh, traditional object-oriented programming is just bad for performance. And if you don't understand why, take a course on how a CPU is built and how data processing in a complex program is actually done, and what makes a program slow and what makes it fast. It's really the CPU being utilized the way it should be utilized. It's not that object-oriented programming is bad or wrong or anything like that. It just matters. Well, we're just doing what's called procedural programming. Traditional procedural programming, or functional programming for that matter. Maybe not functional programming. It would be somewhat hard to implement a program in a functional way, but just procedural programming is just traditional methods and structs. If you want to learn how to do procedural programming, just do C instead of anything else. Just do programs in C. And then when you get the grasp of doing programming in C, you can move to C++ and use the object-oriented features and the extra features. I mean, in this program here, I don't have a real classic OOP object. Not a single one. I use the word class, but the class is, for instance, if I do, uh, for instance, uh, this is the most class-like stuff I have, and uh, it really doesn't store anything other than a series of vectors. This is also a series of vectors. So it's basically just a data storage. I mean, the render API is an API, which means that it's not really an object. It's just something that is easy to call and understand in terms of method layout and so forth. But yeah. So if we are here at the first one, we will add the exit gap to our accumulated distance. Yeah, I did. It's really good. It's not expensive. Okay. Uh, Let me post a link. Let's see. Okay. No problem, man. Go blog. I did the month. I think it's like it's not that expensive. Um okay, maybe I should end the stream soon. I got a lot of work done today and I'm getting a bit tired. Let's see. So I'll give this one. Let's go. So the distance between the objects, distance between object 0, which is at the exit gap position, uh, and one. Well, we create the. Okay, yeah, maybe. So it should be pretty big, right? Yeah, so we just want to calculate the distance between whatever object we have. Maybe we don't even want to do this. Let me see. So we have the exit gap. That's the first item. Hello, how are you doing? Um, so we created at like the position of this. So for the first one, equals. So for the first one here, that's the distance. 1, 0. Okay, and if I wait, 2. Okay, that's more reasonable. Let's see, GXE call print, added this. Okay, it doesn't proc. Let's see. Oh, I know why. Oh my god, I'm so freaking tired. That's why it doesn't work. I'm sorry about the shouting. I of course don't add the item. I don't add the item. That's why nothing is happening. I can't render an item that's not there. At least now we spawn 2 items. I don't think it was correct the way I did it. Let's see. Yeah, definitely not right. There's a bug somewhere. Uh, okay, but no, that's silly. Let's see. Oh, maybe. Yeah, yeah. I use RenderDoc all the time. It is really nice. But this is not a rendering problem. This is a logic problem. Entry gap here. Yeah, I am. Lower than right now. Uh, let's see. Let's see. Let's increase it. Okay. Yeah, so now I can actually do float, or let's wait a minute here. Entry gap. Entry gap here. So if we're the distance should be between the so if we try this float test, and test should be our length. No, it's the distance between if we have the entry gap at the start, and then we have the exit gap at the start or end. And then we have the item here. First item, or rather, item 0. And the entry gap is the distance between the start of the conveyor belt, which is basically what we're trying to compute. So the entry gap whenever a new item enters the conveyor belt is the distance between the last item on the row and the new item. So we should just and let's see. Yeah, this will happen the first time. So let's add the entry gap here. And we also need to reset it, of course. Because now it won't be anything because we just added an item. Okay, it's not working correctly because it's adding from the wrong side, but it's close. Okay. It's not correct, but it's not correct. But we're getting somewhere. And yeah. Let me create an ImGUI panel here. Temp panel. Oh, it's already in the app, right? Yeah. Where's the... Let's debug the ImGUI stuff here. Text. Entry gap. Oh, the entry gap. Exit gap. Okay. Oh, it doesn't show. Oh, it's only when I whoops, when I click the button. Oh, and of course I need the floats here. Okay. Oh. Yeah. Oh, it should be reset, right? Yeah. Also, the entry gap should be reset. Of course, maybe this fixed it. Yeah, it works. Great stuff. So this works for the spawning of the objects. So now we just need to change our update logic. Okay. Okay, so if we are able to if we have an exit gap, so exit gap distance between first item and end of belt. If it's not over 0, we know that um, let's do a for loop here in I less than the let's see gaps, gap index, no, gaps dot size and I++, no. So whenever we create this gap index, we will know maybe. Actually, I want to flip it. I actually want to flip it. So I want to process first gap. So if I do something like for int I and I less than no, let's just update the next one. Okay, let's calculate an index from our uh, gaps. So this follows. So if this is, for instance, 2 and this is 2, we will map to the first one. But when this decreases, this will not decrease, and therefore we will take the next one. Okay, so if we have a gap index, the index let's see, gaps index minus equals 0.5 if it has, I'm sorry, maybe I don't know, is it all right now? Maybe I just moved the microphone. Let's see, so if we're in a state where this is equal 0 here, we'll decrement the gap index. Okay. Okay, let's see, so these are moving. Okay. Uh, and let's see. So I create these two objects here. And there we go. Okay. It's not perfect. So the entry gap stuff. Um, I don't know. Depends on how you define it. I can't really say for certain. I've been doing it as a hobby maybe for a couple of years, but I don't work with programming, so progress is sometimes slow. So this entry gap stuff here should of course update correctly. Uh, yeah, I definitely don't think the entry gap stuff is correct. So, I mean, the entry gap stuff. And also this offsets the starting position of the thingy way too much. Okay. Yeah, definitely it's because of the entry gap kind of like overflowing. Let's see, minus gaps.size times 0.5. Let's try to cap it like that. So it can't be and 7.5. Is that correct or what? 7. I'm not sure it's correct. But let's see. Let's add some more here. So this is 1.5, right? Actually, the entry gap is correct then. Well, well then it disappears uh, for some weird reason. But okay, this kind of like fixed the whole entry gap stuff. It depends. Are you used to programming or? All right, I'm gonna probably end the stream. So today we created a beginning of this conveyor belt system here. with help from the guys at Factorial. Also, I created the iron processor and recipe system with a highly efficient pipeline for processing resources with inputs and giving specific outputs. The application now has a way to create simple recipes by just calling stuff like this. Yeah, I'm tired. I'm gonna end the stream now, buddy. So a recipe takes a series of inputs and of course the amounts of whatever input we take, and then gives a series of outputs, and then it has a tick time. Hi there, how are you doing? Also, I implemented the where do you call it, the window down here that shows us the different states of different buildings, so it can show how much iron we have accumulated and the tick time for our resource extractors. And yeah, you can see that it has no more resources, so therefore it doesn't increase in content. Yeah, so when this conveyor belt logic here is done, yeah, there's a problem there. Let's see. Let's see if this messes up. But yeah, anyway. Oh, this. Okay, it just continues on off. Anyway, thanks to everyone who tuned in, supported the channel, and interacted with me during the stream today. I hope you found it helpful, entertaining, or maybe just inspirational. If you want to support the channel, please consider commenting, liking, or subscribing. There's also more info in the description down below. I'll probably continue on the project tomorrow. Yeah, where I'll mess a bit more around with a more robust code for the belt system. Also, we need to fix the interpolation between frames. Right now, it's kind of like choppy, and it shouldn't be that choppy. So we'll fix that. Anyway, please take care, everyone, and I'll see you guys around. Bye bye.